Hello, my name is Nabil Mahmood. I represent Aramanthia, which is the company that created the Hercules 4 drone. This is a feral hog control system that is designed to help control and cull the population of feral hogs that currently affect large parts of the Midwestern and Western United States. So in this presentation, I'll be giving you guys a rundown of our system, what it can do, how it works, and how it will help farmers across the country deal with pest problems and ultimately save them money. So before I get more into our feral hog control solution, I'll go ahead and give a quick rundown of the stakeholders of the project. So there's us, Aramanthia, which includes the project managers and the project team members. There's people who are pitching it to, in this case, sponsors and investors or executives. There's advisory groups that we work with to help design our product. There's suppliers that we also work with to source the parts for what we make. Government agencies, most notably the FAA and also the United States environmental agencies that deal with wildlife. And at the end of the day, there's also going to be the customers and users who are actually using the product. So these represent the big stakeholders of our mission. So of course the entirety of the project is defined by the need. So in this case we've identified a need as a drone or system that can accurately and efficiently detect the presence of feral hogs on property or other invasive or pest species and alert the landowner. In addition, it must take tangible steps to help landowners cull the feral hog population accordingly. So we've really divided it into one, detect that these hogs are in the presence of a given plot of land, and two, it must take action. So it actually has to take steps in order to help control the hog population. So as I touched on a little bit previously, some of the goals are we need to create a drone that can accurately differentiate between different animals to identify specific pest species. It needs to be able to detect hogs with methods other than visual because hogs are they're known to be nocturnal creatures. We need to create a drone that can survey large amounts of land relatively efficiently, and we need to implement and design algorithms that are effective at herding hogs. So how are we going to get the drones to herd the hogs in a way that will accomplish the mission? So in keeping with the goals, we have our specific objectives. One is to develop a system that uses different types of sensors to identify specific animals. We need to experimentally develop a system that is effective at scaring and herding wild hogs using sounds, gas, or other, as depending on laws that apply to our system. Use a pre-existing or slightly modified drone as a platform to mount sensors. This is a lot in terms of cost and how flexible our system is. And of course, the bottom line, we need to keep costs down and efficiency and reliability high so that it's not too expensive to operate the platform. And if it does cost a bit of money, that would mean that the efficiency and reliability are high enough to justify the price tag. So of course the use cases for the drone are farmers looking to get rid of pests, government or wildlife organizations wanting to sponsor programs to get rid of pests, or landowners simply wanting to protect their property from pests. So now that I've kind of gone through a high-level overview of what the company is and who the stakeholders are and what our goals and objectives are, I can go ahead and start giving you an actual specific concept of operations for the drone. So the primary means through which the drone will control the hog population is through herding. So basically they're going to move in such a way that the hogs will be forced to move away from them. That's the entire idea. Fleets of multiple drones will be launched from a home base to scan across a predetermined field area, in which case this will probably be the plot of land that the farmer or landowner owns. The drones will sweep the area using an efficient searching algorithm until a hog or a pack of hogs are found using the specific sensors that we've designed. And once this happens, the fleet of drones will begin to converge and also will begin to herd as many of the hogs as possible into a predetermined holding area. So again, this is kind of going back on step one is to identify that these feral hogs are on the property, and step two is to start taking tangible actions in order to actually help cull the population. So once the hogs are trapped into the pit, they're left there to be dealt with by the farmer or landowner, however he or she chooses. And after capturing a hog or a group of hogs, drones can either continue with their sweeps or retire to the base to be recharged. So kind of to give a graphical overview of this ConOps, start going from left to right. So you can see number one, the drone fleet autonomously lifts off towards the beginning of the evening, since the hogs are mostly nocturnal. They're going to lift off towards the evening to begin patrolling for hogs in a given area. And they can also be controlled manually. So there's also that option of human override, which is an important part of making sure that the drones are legally compliant. Number two, as hogs are detected with the specialized sensors, the drones begin using herding algorithms to collect the dispersed hogs. So you can see kind of on the green field that's there, once the hogs are found, the fleet of, in this case, 3 drones start to move them towards the holding pit. Number three, the hogs are herded into a holding pit for termination by the landowner. So again, that's the tangible action being taken. And number four, once the mission is complete, the drones can return to base for recharging, or if they're damaged, they can return to base for repair, or if their battery level permits, they can continue on their sleeping runs to find more hogs. So to give a sense of time for the ConOps, this is a rough operational timeline that the mission would follow. So at the start, of course, you charge your UAVs and establish the ad hoc network that is required to control the drones. And then you hit your launch time and you will maneuver to the required altitude, at which point you'll fly the programmed route and start collecting data with your sensors. Next, you're going to identify the hog targets, and if they are identified, you're going to start tracking them and adjusting route toward hogs as needed. Once that happens, you start herding them and removing the hogs or holding them to a predetermined holding pen. And once that mission is over, you can either continue or you can start flying back to the command post if the battery is low. At the end, you dock and land at command post, and that signals the end of that specific mission. So that's the entirety of the operational timeline in an ideal situation. So of course we want to make sure that we're compliant with as many of the federal regulations as possible. So one of the most important ones is whether or not we're even allowed to use drones to cull the feral hog population. So taken from Texas Parks and Wildlife as an example, feral hogs are unprotected, exotic, non-game animals. Therefore, they may be taken by any means or methods at any time of year. There are no seasons or bag limits. However, a hunting license and a landowner permission are required to hunt them. So according to at least Texas law, we are allowed to use drones to herd the feral hog population, and it's kind of an added layer of security that the drones themselves don't have guns. The landowner has to go and kill the hogs once they're in the holding pit. Here are some more federal regulations. These are taken specifically from the FAA. One of the regulations, somebody needs to be inspecting the drone during operation, so there needs to be a line of sight. We need to take, so a solution to that, there needs to be an alert system when the drone takes off automatically so that someone can at least watch them. Regulation 2, the pilot needs to take control when necessary, so there is a safe transition between auto and manual control in case something does come up. Regulation 3, you can't fly at night, but it is possible to get around this by getting a permit before using night fly mode because hogs are nocturnal, so that's going to be one of the primary mission definers. In Regulation 4, you can't fly close to other aircraft, so the flight pattern is going to use a parallel path search, and a bright anti-collision light must be added to reduce accidental collisions that might happen. So as part of this presentation, we've also prepared a project timeline to give you a rough idea of how long this entire endeavor will take. So currently we're in pre-phase A, which is concept studies. So basically this presentation, we've outlined needs, goals, objectives, and things like ConOps. We're heading to move into phase A and phase B, which is where we start to take our sensor and tracking technology that we've developed and laying out if it actually works and bringing it up to an appropriate technology readiness level. This is also the time where we determine exactly what constitutes a mission success and what minimums there are in a certain mission, where we conduct our trade studies, and when we complete the entire design solution. This moves on into phase C and D, where we actually start designing the drone. So in this design process, we make sure that it meets the requirements that we as a company have set out that we have a company have established to make sure that the drone meets them. And this is also when we complete our final design drawings and finalize a production design, and when we begin fabrication. Phase D is when we assemble the system and we integrate and test it, and also make sure that it complies with all the requirements that the customers have set. So we verify those requirements. Phase E is when we move into sustainment, and we look at the units already in use and make sure they're working as per customer requirements. And several years down the line after that, we move into closeout when the product is due for a generational update. So we do a disposal review, and then using the old systems, we complete a system disposal plan. So this timeline is roughly about 13 years. That's how long we plan to operate this generation of Hercules for. So this gives a rough overview of that. So on this slide, we have three of the primary subsystems that make up the drone, which is the actual drone subsystem itself, the AHIDCS subsystem, which is communication, and the ground control subsystem. So on this slide, it's a very high-level overview of what these entail and what their respective subsystems are. So as an example of how we've developed our subsystems, this is the sensor subsystem. So we set out requirements such as the drone will have sensors that can detect a hog within a 150-foot radius. It should be able to detect the hogs when they've left the farmer's field, and it should be able to provide a video feed to a human operator to help maintain that line of sight and for the human operator to better establish control when necessary. So some of the components that would be in the subsystem are a GPS receiver, a high-quality camera, an infrared sensor, and an altimeter to make sure that the drone is flying at correct mission altitudes. And another subsystem that we have is our ad hoc network, which is basically the communication subsystem. Of course, the components of this are the drones themselves and an antenna, the path routing algorithm which we've developed, and a transceiver on the drone itself. So the hog tracking subsystem is really at the core of the product that we're designing. It's at the core of the Hercules 4 drone, and the requirements for it are that the identification algorithm that the subsystem uses should be able to identify and differentiate up to 20 hogs within 150 feet. And along with that, it needs to be able to extrapolate data to predict the future position at a small time interval, and it will do this very rapidly of a herd of up to 20 hogs from the sensor data. And the components for this subsystem are the identification algorithm and the tracking algorithm. So to summarize what we've talked about in this presentation, Hercules 4 is a robust and effective UAV-based solution to driving feral hogs and other pest species from private property, as well as providing viable options to cull the population. We hope that you will consider Aramanthia and the Hercules 4 drone as part of your solution to pest control. This concludes the presentation, but in the next slide we have the team member work breakdown. So the work was divided between 6 team members: Kevin Baliga, Indiana Dawson, Hyun-Ki Lee, Nabil Mahmood, myself, Tatum White, and Matthew Yates. This concludes the presentation. Thank you.